All right, hello and welcome. Today we're going to be doing something really cool. To do it, I have set up an EC2 virtual machine on Amazon AWS. This machine has a NVIDIA Tesla T4 GPU in it. I'm going to need a beefy GPU because we're going to be doing something very computationally intensive. I'm going to take a set of photographs of the same object from different angles, somewhere between 80 and 100 photos, and I'm going to combine them automatically into a 3D model of the object using a technique called photogrammetry. So again, to do this, you need to have a bunch of photographs of the same object from different angles. Like you can see I have here, I've got photos from different angles in roughly the same lighting of this starfish. And we're going to use an open source tool called Meshroom that will do the whole end-to-end process of identifying the feature points, computing the 3D geometry of the object, and then texturing it so that it looks realistic and maintains the texture it had in the photos. So I am going to take you step by step through setting this up. I've already installed Meshroom. You can just get it from the link in the description. It's already on my path, as you can see here. So when I type Meshroom into the terminal, it should just start up right away. Once it's started up, I can drag and drop the images from this folder into the Meshroom workflow. And then you'll see in a minute, once it's started, that there's sort of a pipeline or workflow at the bottom of the Meshroom GUI that contains all the steps that we're going to conduct. And I apologize if this is a little bit blurry. I did shoot this in 4K, but this is a remote desktop, and the tool I'm using, DCV, the tool I'm using to view the remote desktop, tries to optimize for speed. So I was in Beijing when I recorded this. This machine is in California or Oregon somewhere. It's on the West Coast. So pretty significant distance. As a consequence, things might be a little blurry. So you'll see I'm going to File, and I'm going to go to Open. I'm going to find the folder where my images are, which is this one. I'm going to select all of them, and then I'm going to click Open, and they'll be inserted into the workflow. So I just hit Control A to select them all. I clicked on Open, and you'll see it's now pulling them in. And I can preview them in here. I can decide which ones I want to use. I could throw some of them away if I feel that they're not ideal, if I don't want to use them as part of computing my model. But they all look good. I've pre-previewed them. I know what they are, so I don't need to add anything here. Yeah, okay, so we're going to save this project, and then we'll go ahead and run it. And you'll see, actually, if I right-click on any of these nodes, or excuse me, left-clicked on any of these nodes down here, it'll show me what they are and what they do. Basically, we're doing feature identification and texturing and whatnot to produce the final model. So let me see if I can make this a little bit bigger so that you can see what's going on. It doesn't look like there's any good way for me to make that bigger, except maybe to drag this up a little bit. No, sorry, it's still really small. So you know what? We'll just skip ahead to when we're ready to run the workflow. Sorry about that. If you're running this on your own computer, you should be able to use your scroll wheel or pinch zoom to see those, make them a little bigger. But again, just to give you the general idea, each one of these nodes represents a step in the workflow from identifying the features to producing the final textured 3D model. These default nodes that are in here are fine, at least for someone like me that's not an expert at photogrammetry. I found that the default ones are fine. When you're ready, you just click Start at the top of the screen like I just did, and then the workflow will begin to run. And be aware, this is going to take some time. So actually, let me just show you. You can actually see that this is now running and using GPU capacity. If you run NVIDIA-SMI, Meshroom is showing up as one of the processes that's utilizing the GPU, as it should be. This is a very GPU intensive thing. This is going to take anywhere from half an hour to an hour on this set of images to produce a final model. So again, you can see that this is running. It's using up a ton of memory and CPU and GPU. That's all normal. That's all to be expected. That's actually why I'm running it on a virtual machine instead of my local laptop, because I'm going to have to walk away and do other things and then come back to this in 30 to 45 minutes from now when it's actually done. Let's do that. Let's actually fast forward to when things are complete and it's finished running. All right, and thanks to the magic of video editing, we're done. And this little point cloud here is actually a set of the photographs, the computed positions of the photographs relative to the 3D model. So it sort of works out what angle the photographs must have been taken from, which of course is a necessary step to actually computing that final geometry. This last node here actually does texturing, and if we look closely at the settings for this node, it will tell us where the final model is. There should be an OBJ file and some texture files. You'll see I've actually opened those up by getting the path from that node. There's an MTL texture file and an OBJ file for the 3D model itself, and then some logs and stuff. And I can actually go and open those up in another tool like Blender, and we'll actually be able to import the model in alongside of its textures and preview it in Blender. Okay, cool. So first thing I need to do is delete the default Blender cube here. You can see it's highlighted in orange, which means I've selected it. Once you've selected, you can hit X to delete. So I'm going to hit the X key. That brings up the delete menu. I click on delete. Now the cube is gone. Fantastic. So next up, we want to go to the import menu, and there's a lot of different file types that Blender supports when you're importing a model. Meshroom made an OBJ file, so that's what we're going to pick. I'll go to downloads, I'll go to Meshroom cache. Way down in that bottom folder, texturing is where the OBJ file is and the MTL file with the textures. I just click on the OBJ for now, I ignore the MTL file, it will auto load. And I wait a minute or two and then the model will load up. This can take a minute the first time you do it. The meshes that are produced by Meshroom are very large. So in this case, I think that OBJ file was almost 200 megabytes, something like that. So it can take a minute to load in. And when your model first loads in, don't be surprised if it looks weird. It's going to look like clay or putty. The view that we've got turned on right now is the modeling view. It's not the rendered view of the model, which means it's missing all of its textures. If I want to render it with textures, I have to click one of these two little globes in the upper right-hand corner. If you can see me, I'm doing that. I'm clicking in the upper right. Either one of those two on the far right will enable texturing of the model, and you can see now the colors appear correct on that model. So again, either one of those will work fine. I believe one of them uses cycles and one of them uses EV or something. I think they use different rendering engines. I'm not really a Blender expert yet, but either one of those two little globes on the right-hand side will render your model with textures. One of them might be faster than the other. We'll leave it at that for now. So what I want to do next, and this is the part where it's going to fail, and I'll explain why in a minute. What I want to do next is export the model here using this file format here. So you'll see this is a GLB file. When I do the export, it's going to fail. The reason I wanted to export to GLB is that it packs the 3D model and the textures together into a single file, and some tools, like Microsoft OneDrive, actually have a built-in previewer that works for GLB files and renders them with texture. So I was going to try to do that, but you'll see immediately I've got this Python error. And I'm going to show you what I tried to do to fix this, even though it turned out to be the wrong thing. My actual problem here turned out to be that I'm using Ubuntu 22, and this is a very, very old version of Blender that is installed from the Ubuntu package repositories. In the end, what I actually did to fix everything was I went to the blender.org website, I downloaded the latest copy, and boom, everything worked, right? I thought, because of what was in the error message, that this was genuinely a complaint about missing Python packages, which is why I'm doing all this Python stuff in the video. Turned out I was totally wrong, had nothing to do with that. It was actually because of an old version of Blender. But anyway, we're going to take a quick break and I'm going to show you how to install Anaconda Python distribution, just because it's a good thing to do. Later on, we'll need it when we do like machine learning videos and whatnot. So let's just get it out of the way now. Okay, so I'm on the Anaconda download page already. I'll leave a link for this in the description, and I'm downloading the 64-bit installer for Linux x86 because that's the architecture of my EC2 instance that I'm running on. And you can see, even though it's a gigabyte, this is quite a fast download, right? Which makes sense. Again, I'm running this on Amazon AWS in the cloud, so I've got a pretty solid internet connection. These sorts of things should be fast. I'm actually going to clear my downloads first because I'm anal about that. Then we're going to switch over to a terminal window and actually run this installer. So if I go over to downloads, I should be able to find the installer. You can see Anaconda 3 install.sh. That's the thing. Hold on, let me fast forward to when we do the install. Actually, you know what? Hold on a second. I'm here in the docs, and there are some packages I need to install in advance on Debian-based distributions. So maybe let's go do that. Let's make sure we've got those installed first before we actually run the installer. Shoot, I forgot sudo. All right, let's do that again. We'll run apt-get update first, just to be safe. And then once that's complete, which is, well, okay, we're done. Then we'll go ahead and run that install command. 100 and some kilobytes of stuff. So I guess that means we had most of the packages already. We'll just wait for these to install, and then we'll go ahead and do the actual install process for the Anaconda distribution itself. The package install here should not take too long. I think in another 20 seconds or so we'll be done with this, and then we can move on to the actual Anaconda distribution installer. So just give me a second while we do that. Although it does, I'm starting to get concerned. It says scanning Linux images. Oh boy, newer kernel available. So what I'm going to do is reboot, and I'll just skip ahead to once we've restarted and updated the kernel and all that. Ta-da! Okay, we're in the future. We're now actually ready to run the Anaconda install script. Oh, didn't run because of that little tilde slash on the front. Let me remove that because I'm already in the downloads folder. Hit enter to continue. That will take us to the terms of service. I have to scroll all the way down to the bottom of those and hit yes to accept, and then enter to continue again. And then that will actually take the packages that are part of the Anaconda distro and install them in home/ubuntu/anaconda 3, which is what's going on now. I'm not going to make you sit through all of that. I will fast forward to once that's all finished installing, which should be right now. We're in the future, and you can see I actually made a mistake. So up here when I said, do I want to run conda init, I didn't do that. I accidentally hit enter instead of typing yes. So that command didn't run. So now I actually need to grab this eval command from the instructions in the installer, and I need to run it by hand. And you can see I've already run it incorrectly once. I was supposed to replace your shell name with my shell name, which is bash. So you'll see I've put .bash and then hook and then parenthesis quote. Now at the front of the command line, you can see the word base appears. That means conda is running. So I'll run conda init, and that will actually take the conda init stuff and append it to my bashrc file. So now every time I open a new terminal window, the Anaconda Python distribution will be running, and I can call all of the conda commands for managing Anaconda packages. So let's double check that. Sure enough, at the end of bashrc, you can see all this conda stuff. That's a good sign. So if I were to close that terminal window and open a new one, sure enough, the word base is showing up at the beginning of the command prompt there. That means conda is running. Okay, that isn't actually going to fix my problem, though. I actually need to go upgrade Blender, so let's do that. Of course, before I do that, I need to uninstall old Blender. So we'll run apt-get uninstall, apt-get uninstall. Why am I doing this wrong? apt-get remove, sorry. Sudo apt-get remove Blender, and that will go ahead and delete it. I'll say yes, I really do want to remove it. Once that is out of the way, you can see I've got the blender.org page open here, and we'll auto remove all these other packages that were part of Blender that Blender was using. We'll really start fresh. So you'll see I'll remove all the orphaned packages too. I just ran apt-get auto remove, and now I'm running auto clean. Great, nice squeaky clean machine. Now I'm going to go to blender.org, and right from that Blender page, let me close some of these tabs. Right from that, oops, shouldn't have closed that last tab, my bad. There we go, blender.org/download. Right from this page, I can download 4.3.2, which is the latest. I think Ubuntu 22's package repo has Blender 3 dot something, super old. So we've now fetched the new Blender. It's a tar package, tar.xz. Let me go open up a terminal and unpack that, and I'll probably have to stick it in user local bin or like add it to my path or something. Oops, sorry, auto completion is not working for me right now. XVF Blender 432. Okay, there we go. Great. Yeah, so it looks like I will just be able to add this Blender folder to my path, and everything should just run. You can see all of the dependencies for Blender are just in the package, so it looks like it's all pre-built and all the dependencies are already linked in. So I'll just be able to add this to my path once it unpacks and just run it directly in place. So let's go ahead and do that. All right, so you'll see I've moved Blender over into the downloads folder. Sorry you didn't get to see that. I switched away a little quickly, but I'm going to update my path, so you'll see where it is. I'm going to update my path to include home Ubuntu, documents, not downloads. Shoot, I forgot what it was too. All right, hold on. Let's open up the Finder. Blender 432. Okay, so I guess that was, and then bin, I think. Nope, just this directory, Blender 432 Linux. So we'll throw that on there. Move that down so I can see exactly what it is. Drag that down a little bit. And again, in Bash RC, I'm going to add that to my path, blender dash 4.3.2 dash Linux dash x64 / Okay, great. Now if I run source.bashrc, let me go back to home first, source.bashrc. Now if I just type in Blender, it should run, and you'll see it's the new one. It's 4.3, I think it should be. So let's wait for that to boot up. Very first time that it runs, it might be a little bit slow. All right, good. Yes, you can see it already looks different than it did before. But of course, the default cube is still there, so I have to hit the X key and then hit delete. Now I should be able to re-import my model again from that OBJ file that Meshroom produced. But this time, hopefully, because I'm running a newer version of Blender with all the correct Python stuff installed, hopefully, when I go to export to a GLB file, it will work. So again, we're going to Meshroom cache, we're going to the textures folder, we're finding our OBJ file, we're waiting for it to load in, which could take a second, we're previewing it. Oh, much faster this time. New Blender is good Blender. Let's render it so we can see all the textures. That part really might take a second. Let's see here. Yeah, I clicked on it, but we're waiting. Okay, so texturing it is taking a minute. That's fine. We'll just try to be patient. Again, it's one of those two on the right. Those two options in the upper right-hand corner there that I've highlighted, those are the ones that will turn on texturing for you. Odd that it's taking so long. Maybe it's just because it's the first time. So we'll wait for just a second and see if that actually loads up on its own. If not, we'll fast forward into the future. Okay, finally. All right, looks like it did it. It's textured now. All right, so we can I actually don't have a mouse right now. I'm using a trackpad, so this is a little tricky, but you can use the sort of, there are these little command icons in the upper right here that I'm clicking on to drag and zoom and rotate. If, like me, you don't have an actual physical mouse that you can use, these are a good hack. Like if you're on a tablet or you're on a machine with a trackpad, those let you drag around. And you can see the model looks pretty good. It's an actual 3D model of our starfish, plus a significant chunk of the stool that it was sitting on. So now what I'm going to do is I'm going to export this to a GLB file, which will contain both the 3D mesh itself and also the textures. Before I do that, though, let's just see if Blender is actually using the GPU, because it was a little slow to start up. If I go to CUDA, yeah, Tesla T4. Okay, so it is. It's just, I guess the first time I start it, it's just a little bit slow. So now we'll go to Export, and we will choose GLB. And we'll just throw that in the same folder as all the output from Meshroom here. I'll give it a name like Starfish, and I'll say export, fingers crossed. I hope it works this time. Again, first time starting it up, so could be a little bit slow. So we'll just have to wait a second. Okay, it's going. It's definitely going. That's a good sign. No crashes yet. I think it's going to work. So this time it should export correctly for us. Great, so let's open up the File Explorer here and take a look. Go to Downloads, starfish.glb. Yeah, there it is. So it definitely worked. And if we go look at the properties, it should be fairly large. Yeah, 221 megabytes. That's about right. It's a very complicated 3D mesh plus all of the texturing info. Kind of expecting it to be large. And just to show you that cool preview trick that I wanted to show off, if I go and I put this into OneDrive, I actually have, I pay for OneDrive, so I've paid for Office 365. They include, I think it's a terabyte of storage. And so great place to store 3D models. If I actually upload this GLB file, the previewer in OneDrive should let me see the 3D model in the web browser, which is pretty sweet. And if I share a link to other people, they will also be able to see it rendered in a web browser window directly without them having to have any 3D software, which is pretty cool. So just to demonstrate that, let me click on this. You'll see it opens up this sort of odd looking window with a beige or gray background. It's loading the model. Your results might vary here. It's going to take a minute. It's actually quite fast for me because, again, I have a really solid internet connection. But yeah, the cool thing is OneDrive can preview these GLB files directly, and it even sort of auto-rotates them. Let me drag around so you can see the starfish. And again, the auto-rotation will start in a second. And there you have it. We have a 3D model, a complete 3D model of an actual real-life scene computed directly from a set of photographs and saved into OneDrive. Pretty cool. All right, that's it for this time. See you next time.